Hi, hello friends. Welcome back to TRB revision series. So, in the last class, we have started electrical measurements already. We have completed two sessions. We have seen the basics. Then we have been discussed about the basics of instruments. So, in the yesterday class, if you have seen the lecture there, you might have seen that we have been discussed about different types of electromechanical instruments. We saw the deflection torque, controlling torque, damping torque, formulas for various type of instruments, and we have seen the difference between linear scale and non-linear scale instruments. Now, by using these instruments, what we are doing is we will be designing the ammeter and voltmeter usually. What type of question will be framed here is, suppose I am having one normal instrument, I would like to extend its instrument reading. For an example, I am having one ammeter, this ammeter having its own internal resistance, and that internal resistance will be treated as R. Now I just wanted to say, I am just saying this ammeter is initially measuring certain current, that is called ammeter measured current RM. Meter resistance I will be considering it as RM. So the current will be IM, that is the initial current offered by the ammeter. Now if you want to extend this range, then how should I extend it? What they will do is, we will be connecting on shunt resistance with this, then that shunt resistance value will be treated as RSH. Now the resultant current, that will be the total current read by the ammeter. Now the shunt current will consume some current, we will be considering it as ISH. So the total current that is coming or it is entering into shunt branch plus ammeter current all put together, that will be the new reading done by the ammeter. Now what they will do is, in the examination you will be requested to calculate the value of this shunt branch resistance. Most of the time this is the question. How should I do it, sir? They will give you the value of ammeter, meter measurement current, and the value of meter resistance and the total current what they are looking for. The extension range will be given. Now you will be requested to calculate the value of RSH. For that I am giving the direct formula. We know the multiplying factor M is equal to, you will have to take the ratio between two current. One is the meter current and another one is the total current. After taking the ratio between these two, directly use this formula to know the value of shunt resistance. The value of the shunt resistance is going to be meter resistance divided by factor M minus 1. That's it. That is the direct formula. So that is all what you have to remember. Next, suppose if you are designing voltmeter in the same way, and if we want to extend the reading of the voltmeter, what can we do, sir? Is there any similar way? Yes. You can perform the same thing. For an example, I'm having the, once again, I'm having the voltmeter, let us take, and the voltmeter having certain internal resistance. This is meter resistance. But in case of, this is initial reading of the voltmeter. Let us take the initial reading of the voltmeter is Vm. Now in order to extend the reading of the voltmeter, what we have to do is, we will be attaching one more additional resistance in series with the existing voltmeter. So the resultant value, now from here to here, the resultant value whatever that we are going to measure, that is the new value of the voltmeter reading. Now the question is, once again they will ask you to calculate the value of RSC, series resistance. Meter resistance will be given, meter voltage, voltmeter reading will be given, initial value, and the new value will be given. The question is, find out the value of series resistance. Same formula you can use. Series resistance equal to meter resistance, but for voltmeter the factor will come in the numerator. And what about the value of M? There will be no changes. Once again, that is the ratio between the value of Vm by Vm, that will be given. So meter resistance will be given and the total value will be given. So here I took, okay, this is V. So then take the ratio between V by Vm. That is how we are calculating the value of meter reading. Here also, see, I took Im, this one, no? So here, sorry, change this. Im will come in the numerator, denominator, because in the numerator total current should come, in the denominator whatever the reading that was given yearly, that should come. Now after taking the ratio between this, you can explore the value of RSH. So Im is nothing but the meter reading that will be initially consumed by the ammeter, that is the initial current passed through the ammeter. Similarly, Vm is the initial voltmeter reading, V is the new voltmeter reading, I is the new ammeter current. So do remember the difference between these two, because repeatedly questions will be framed by using this concept. Now, the next topic is, 1 second, sir. What we have to do is, the next type of question, what they will frame is, you will be requested to calculate the sensitivity of this voltmeter. The another question what they will do is you'll be requested to find out the sensitivity of the voltmeter. Sensitivity of the voltmeter. Most important question, repeatedly asked the question. So sensitivity of the voltmeter equal to, whenever they are asking, what you have to do is just to take the reciprocal for the full scale deflection current. The value will be given for the voltmeter, the full scale deflection current rating will be given. Just you will have to take the reciprocal for that. And it can also be written as, listen, full scale deflection current can also be written as full scale deflection voltage divided by resistance. If the value of the resistance and the full scale deflection will be given, then by taking the ratio between, according to from the mathematical derivation of Ohm's law, we know I is equal to V by R. From this you can calculate the full scale deflection of the current, then take the reciprocal for that, then you can easily calculate the value of sensitivity. This formula is another most important formula. Now let's see the next formula is, the next thing is, till now we have seen whatever the equipment that we have seen, with the help of them we can measure voltage and current. Now the next task is, sir, how should we measure the power? What is the formula? Let us discuss about power measurement. Keep that in. Next we are going to discuss about power measurement. As we know, the real power is nothing but it is the product of RMS voltage into RMS current into cosine of power factor angle between them. That is the formula to obtain the power. This is for single phase power. Suppose if you are measuring three phase power, then it will become root 3 times of line RMS voltage into line RMS current into cosine of phase angle difference between them, or 3 times of per phase RMS voltage into per phase RMS current into cosine of phase angle difference between them. Factor root 3 will come when we are using line parameter. 3 will come when we are using per phase parameters. Remember these equations. This is for three phase system. The second one is for three phase system. Now the question is, how we are measuring this power with the help of electrodynamometer wattmeter. That is the next question. How we are measuring this with the help of electrodynamometer wattmeter. Electrodynamometer wattmeter. So electrodynamometer can be used as a wattmeter here. Electrodynamometer can be used as a wattmeter in order to measure the power of a circuit, power of a load, whatever the things that you are looking for. Now here we are having an electrodynamometer type of wattmeter. We will be having two type of coil. One is called fixed coil and the second one is called moving coil. We will be having two type of coil. One is called fixed coil and another one is called moving coil. Now what will happen is, the fixed coil is usually carrying the current. Fixed coil is usually carrying the current. That is nothing but current carrying coil, and the current through this coil we can consider it as IC. Moving coil is nothing but usually this will be connected. Moving coil is non-inductive coil, we can say, or we can say it is highly resistive coil. Moving coil is generally highly resistive coil, you will have to remember, or we can consider it as non-inductive coil. It means the value of inductance is very less in case of moving coil. So the moving coil is also called a pressure coil. This is dealing with the voltage. This pressure coil is dealing with the voltage measurement, and the current coil is dealing with the current measurement. So this is called current coil. Fixed coil is also called current coil. Moving coil is also called pressure coil. That is the another two important point that you must keep in your mind. So with the help of this current coil and pressure coil offered by the electrodynamometer, we are going to measure the current taken by the load. With the help of current coil, we will be calculating the current taken by the load. With the help of the pressure coil, we are measuring the voltage drop, that is voltage across the load. Once you measured these two values, then with the help of these two, we can easily measure the value of power. As we are observing, from the pressure coil, you can take the voltage. From the current coil, you can take the current. Then cosine of the phase angle difference offered by these two people. That's it. That is how we are measuring the power with the help of electrodynamometer wattmeter type. Now here, what is the most famous question, sir? The question that will be repeatedly asked here is, I will tell you. As usual, this electrodynamometer is also having its own deflection torque. What is the formula to obtain the deflection torque when we are observing the electrodynamometer? So it is having two coils. One is pressure coil, another one is current coil. So what we have to do is, we will be considering the pressure coil current and the current coil current. So we are going to consider the value of, pressure coil voltage and current coil current. We will have to play with two coils. After that, from there, we will be bringing from the pressure coil voltage, we will be bringing the pressure coil current, and then pressure coil current, and then sorry, current coil current, and the cosine of the phase angle difference between the two quantities, and then the mutual inductance offered by them with respect to the deflection theta. So that is the formula to obtain the value of deflection torque. And the formula to obtain the controlling torque, electrodynamometer wattmeter. As usual, it is k times of theta. Under steady state, the deflection torque and the controlling torque are both will become equal to each other. From this, you can explore the value of theta when it is being asked in the examination. Okay. Hope you all understand. That's it. Now, when we are observing the electrodynamometer wattmeter, the another most important area is we will have to calculate the value of. You will be requested to calculate the error, correction factor. There are true power measurement, capacitor value. They will be usually asking four type of repeatedly asked questions are there. The first one is the formula to obtain the true power from the given data. There are certain derivations are there. Now I will be writing all the power formulas. First one, if you will be requested to calculate the value of power formula, they will give two data. One is the value of the power factor cos pi, and another one the value of beta, that is the pressure coil phase angle. I will tell you cos pi divided by, first write down the formula, cos pi divided by cos beta, that is the formula, cos beta into cos of phi plus or minus beta. So this is the formula to obtain the into actual reading of the wattmeter. Sorry, I forgot to give on this, into actual reading of the wattmeter, into actual reading of the wattmeter. Now in the question, actual reading of the wattmeter will be given. What is this pi, sir? Pi is nothing but the phase angle difference between the load voltage and the load current. That is the power factor angle that will be given. Whereas beta is nothing but the phase angle difference of a phase angle offered by the pressure coil voltage versus pressure coil current, that will be given. So we have seen there are two coils, one is current coil and another one is pressure coil. So the pressure coil angle will be given. Directly you can take it from here. Substitute everything into the formula, cos pi divided by cos beta into cos of pi plus or minus beta. So here the formula, negative for lagging load, you will have to use negative for lagging load and positive for leading load. That's it. Hope you understand. So this is the formula for obtain the true power. Next, sir, if the true power is given and actual reading also given, how to measure the error of the wattmeter? The next question is error of wattmeter. So the error of the wattmeter can be directly obtained if the value of tan theta and tan phi. See, if the value of beta and the value of pi, let us see both are given in the question. Let us assume both are given. Then how should I measure the value of error? Error equal to, directly what you can do is take tan phi, calculate the value of tan of pi and tan of beta, and multiply it by true power. That's it. Multiplied by true power. That is the direct formula. You can calculate with the help of this. You can calculate the error of the wattmeter. Repeat one more time. Tan phi into tan beta into true power is the formula to obtain the error. Okay. Suppose if Vi cos pi values are given. See, true power is nothing but what? Voltage, pressure coil voltage, current coil current into cos pi power factor, phase angle difference between them. So if it is given, then calculate the value of true power first. From there you can explore the value of error value. So this is fine. Next, what they will ask is, you will be requested to calculate the value of compensation capacitance that we are using in our electrodynamometer wattmeter type. Actually, this compensation type of what we'll be doing is, we will be connecting a capacitor in parallel with the resistance coil, pressure coil resistance, in order to compensate the effect of the pressure coil inductance. As we are saying, there are two coils, one is called moving coil and another one is called fixed coil. Moving coil is nothing but pressure coil. In case of pressure coil, we will have the effect of inductance as well as resistance. But I just wanted to keep it as a highly non-inductive circuit. I told pressure coil must be highly non-inductive. So we will have to compensate this effect of this inductance. In order to compensate this effect of the inductance, we will be connecting a capacitor in parallel with this coil. This overall coil, you can connect like this. Okay, that will be better. 1 second. Yeah, sorry. So we'll be connecting a capacitor that is overall with this coil. Okay, fine. Just leave it. So what you have to do is, there is a resistor and inductor. Across this we'll be connecting a capacitor, that is compensation capacitance. Now the question is how to calculate this compensation capacitance. That is the formula. So that is the question. So it is 0.41. The formula is there, 0.41 times of L by R square. L by R square. R is nothing but pressure coil resistance. L is nothing but pressure coil inductance. Both will be given. So LP by RP square into 0.41. From the derivation directly we can calculate the value of common section capacitance when it is being asked for electrodynamometer type of wattmeter. Don't forget, sir, this is very important term. Okay. And the next thing is, what type of errors that will be occurred in wattmeter whenever we are discussing about the basic properties. See, I will tell you what we must remember here is, one second guys. Okay, just give me a second. Slides are very less. Let us increase this slide. Okay, done. So let me continue. The next question is, in electrodynamometer wattmeter type, while designing electrodynamometer type of wattmeter, we can design the wattmeter in two ways. I will show you the circuits. First one, directly current coil will be connected with the load and a pressure coil will be connected like this. This is one type of connection. We know usually wattmeter will be having four terminals. Correct, na sir? It is always having four terminals. So when we are observing, it is having four terminal. Load terminal will be directly connected with the load. Common terminal will be available here. Voltage terminal will be connected between these two, and this is the main terminal we can also call. So main terminal versus common terminal we can take. This is because they will be connected together now. So main terminal and common terminals are attached together. Voltage terminal will be connected here, load terminal will be connected here. Anyway, let us come to the conclusion. This is pressure coil voltage, this is current coil current. This is current coil, pressure coil. This is one type of connection. Now the second type of connection is current coil will be given. After that directly pressure coil will be connected. Pressure coil will be connected like this. Then you can observe this is the load. So there are two type of connection that we are observing. In the first case, current coil will be directly connected in series with the load. In the second case, pressure coil is directly connected across that is parallel to the load. In both cases, what type of error will come? How should we calculate the value of error? That is very simple. When the current coil is connected in series with the load, then directly calculate the error like this. The error is current flowing through the current coil into resistance offered by the current coil divided by the true power, that is load voltage into load current into power factor angle cos phi into 100. This is true power in the denominator. So in the numerator what we are having? The current coil loss divided by true power, that is the formula. Directly you can obtain the error. Now, suppose the second case. If the pressure coil is directly connected across the load, then what will be the error? That is the second connection. In second connection, directly calculate pressure coil square divided by RC, pressure coil power loss divided by true power into 100. That's it. Pressure coil is nothing but, pressure coil voltage is nothing but load voltage. In the first case, current coil current will be equal to load current. In the second case, pressure coil voltage will be equal to load voltage. Because in the first case, current coil connected in series with the load. Whatever the current that is flowing through the load, same current will be flowing through the current coil also. In the second case, pressure coil connected in parallel with the load. Whatever the voltage that will be available across the load, same voltage will be appeared across the pressure coil. So these two voltages will be same again. So with the help of these two formula, we can easily explore the errors because of the wattmeter connections. Don't forget, this is one of the most important area that you must remember. Next, let us discuss about wattmeter reading. So the another most important area is measurement of three-phase power using this wattmeter circuit. Measurement of three-phase power. Measurement of three-phase power using wattmeter circuit. The most effective method to measure for the measurement of three-phase power is 2 wattmeter method. Most of you might be aware of it. 2 wattmeter method. The most effective method is 2 wattmeter method. Now the question is, with the help of 2 wattmeter method, if we are measuring the power, for an example, if a load is given like this, a three-phase, let me take a three-phase star connected load. If it is given like this, how to measure the power? I will show you how to measure the power now. Let us say this is three-phase circuit now. In this three-phase circuits, if you are observing, there is a pressure coil. This is current coil and a pressure coil. Wattmeter 1. Let me connect it with the phase B. Sorry, RBY I am taking. Again, let us take, there is one more current coil and I will be taking, this is wattmeter 2. This will also be connected here. So let me extend this line. Now let us take R. You can take any one sequence. See, this is R, this is Y, this is B terminal, RYB. From R 120 degree phase shift Y should come. From Y 120 degree phase shift B should come. So RBY is the correct reading here. Now after connecting the reading like this, anyway, ultimately what we have to do, our responsibility is to measure the value of wattmeter 1 reading and wattmeter 2 reading. Now what is the formula to measure the value of wattmeter 1 reading, sir? The formula is the voltage, line voltage offered by pressure coil of the wattmeter 1 will give you the line voltage. I'm sorry. Current coil of the wattmeter. So this will offer current coil of the wattmeter 1 will give you the current, and the pressure coil of the wattmeter 1 will give you the voltage. From this, with the help of this, wattmeter 1 is nothing but line voltage into line current into cosine of, the formula is 30 minus pi, and assume the nature of the load is lagging. The formula that I am giving for lagging load. If the load is lagging, then the reading of the wattmeter 1 is going to be line voltage into line current into cos of 30 minus pi. What about the reading of wattmeter 2, sir? Wattmeter 2 reading will be line voltage into line current into cos of 30 plus pi. Don't forget, these two formulas are very, very important formula. Sir, suppose if the loads are leading load, then what shall we do? If the loads are leading load, let us take the loads are leading load. If the connected load is leading load, then what shall we do? Then wattmeter reading will going to be, line voltage will be given, line current will be given in the question. Directly explore the value of wattmeter 1 reading will going to be cos of 30 plus pi. Wattmeter 2 reading is going to be line voltage into line current into cos of 30 minus pi. All the formulas are very, very important. Please don't forget. Now we have seen how to measure these two values. Now the next question is, suppose if two wattmeter reading, W1 reading is given, W2 reading is directly given, W1 or W2 is given. How to calculate the value of real power, reactive power and power factor? That is the next three questions. Two wattmeter method will also be helping us to know the reactive power value, real power value and power factor angle phi. This is not Q, that is phi. I will show you. Now for this, what we have to do is, we must know the formula. See, for an example, I will tell you. First, the power factor formula, tan pi is equal to root 3 times of wattmeter 1 reading minus wattmeter 2 reading divided by wattmeter 1 reading plus wattmeter 2 reading. That is the formula to calculate the value of tan phi. From this, calculate the value of phi. From this, calculate the value of power factor. That is how we are calculating the value of power factor. Now here in the numerator, whatever the formula that you are observing, that is nothing but reactive power formula. So take the wattmeter 1 reading and wattmeter 2 reading, subtract them, then multiply it by root 3. That will give you the reactive power. Whereas wattmeter real power reading, just add wattmeter 1 reading with the wattmeter 2 reading. That will directly give you the value of real power. Now let us see the various phase angles from here in this equation. Now take this. This is one of the most important question. From here there are so many questions. What people will do in the examination is the question number 1. Suppose if wattmeter 1 reading and wattmeter 2 reading both are equal, then what will be the power factor? Directly substitute. If 1 and 2 are equal in this equation, then W1 minus W2 will become 0. Then tan pi value will become 0. From this we can say this will leads to power factor pi value will be 0. From this we can say power factor cos pi value will be equal to 1. That is one case. Now the second case is, suppose the second type of question what they will do is, if wattmeter 1 reading will be double times of wattmeter 2 reading, then what will be the power factor? If you are keeping that expression here, if wattmeter 1 and wattmeter 1 will become double times of wattmeter 2 reading, then what will happen here? 2 times of W2 minus W2 will become 1 in the numerator. In the denominator 3 will become, that will become 1 by root 3. Yes or no, sir? So if you are from this, if you are calculating the value of pi, pi will become 30 degree. If you are calculating, pi will become 30 degree, because we know tan inverse of 1 by root 3 equal to 30 degree. So if you are calculating cos pi from this, then the value of power factor will become 0.866. Now direct question is, when wattmeter 1 reads double times of wattmeter 2, then what will be the power factor value? 0.866. If you remember the answer, directly you can get 1 or 2 marks. Now the next type of question from this, from here what they will make is, If any one of the wattmeter, let us take wattmeter 2 is reading 0, then what will be the power factor? If one of the wattmeter reads 0 here, see, let us take wattmeter 2 will be 0 here. If I am putting wattmeter 2 equal to 0, this will be 0, this will be 0. W1 will get cancelled. Tan inverse of root 3 will become pi equal to 60 degree. Then the value of pi will become 60 degree, and the value of power factor cos pi will be equal to 0.5. That's it, sir. Now the next question is, suppose if wattmeter 2 is reversely connected, what happens is wattmeter 1 and wattmeter 2 are reading the same value with the opposite sign. If they are reading this with the opposite sign, then what will happen, sir? Just to focus on here once again. If they are reading with the opposite sign, W2 will be replaced by, or W1 will be replaced by minus W2. But in the denominator, if you are doing that, denominator term will become 0. 1 by 0 will become infinity. So pi equal to tan inverse of infinity. That will give you tan inverse of infinity will be 90 degree. From this we can say the value of power factor cos pi will be 0 degree. So when wattmeter 1 and wattmeter 2 are actually reading with this, reading the same value but with the opposite sign, it means the value of the power factor offered by the circuit will be 0. So this formula you must remember, sir. That is the most important formula. And the next thing is, I will tell you the another most formula is, so this is how we are using two wattmeter method effectively. Now the question is measurement of three-phase reactive power using single wattmeter method. That is the next question directly asked in the exam. Measurement of, write down, measurement of reactive power, three-phase reactive power, measurement of three-phase reactive power, measurement of three-phase reactive power using single wattmeter method. This is the beauty, na? Most important topic. Using single wattmeter method, measurement of three-phase reactive power using single wattmeter method. Write down measurement of three-phase reactive power using single wattmeter method. If they are asking like this, then what is the formula to obtain the total reactive power that will be demanded by the, that is supplied by the, read by the wattmeter? In this case, what they will do is, they will take a star connected network. For an example, I am taking, let us assume there is a star connected network will be given. And what we are doing is, we are going to measure the value of reactive power from here. As I told, only one wattmeter will be given. A pressure coil will be given, and that will be connected like, okay, sorry, we are measuring reactive power, na, sir. 1 second. See, pressure coil one line will be connected with this one, and the pressure coil second line will be connected with this wattmeter. Okay, pressure coil has two terminal. This voltage terminal and this common terminal will be connected with the phase B and phase C. Whereas phase A, this is main terminal. It will be connected to the supply, load terminal will be connected to the load terminal. So current coil is separated, pressure coil is separated when we are measuring the reactive power. That is the next conclusion. With the help of these two, what can we do is, actually the wattmeter reading, wattmeter reads root 3 times of per phase voltage into per phase current into sin pi. That is the formula. Now wattmeter reading will be given in the exam, or else you will have to calculate. Remember, here I am putting sin pi because we are measuring reactive power. Do remember that. Then what is the total reactive power, sir? The total reactive power is going to be root 3 times of wattmeter reading. It means root 3 into root 3 will become 3 times of per phase voltage into per phase current into sin pi. So what you will have to do? Wattmeter reading will be given in the exam. Just to multiply it by root 3 to obtain the value of reactive power. If it is not given, then calculate the per phase voltage, per phase current. Whatever the reading that they are giving, pressure coil voltage will be given, pressure coil current, current coil current will be given. Sin pi you will have to calculate because we are focusing on reactive power. Of course, wattmeter reads only V phase, I phase, sin pi only. Okay, but it is root 3 times. Don't forget that factor should come here. While calculating reactive power, don't forget to multiply the factor root 3 with the wattmeter reading because they are little bit very important formula. Most of you are not paying attention in the measurement of reactive power calculations by using electrodynamometer, wattmeter, single wattmeter method. So hereafter, don't do that. Keep these things in your mind because they all are very important. So the next one is energy meter. So we have completed all these things. So the next topic is energy meter. The next most important topic is energy meter. When we are observing the energy meter constant K will be defined as number of revolution by kilowatt hour. You will have to remember that is the formula. Number of revolution by kilowatt hour. Try to practice some problem by using this. because it is very important in the examination point of view. As we are observing, the wattmeter will also be having two types of coil. So when we are observing the wattmeter, you can observe that it is having pressure coil and this is also having current coil. And the pressure coil here, in case of energy meter, we are in energy meter, pressure coil is highly inductive in nature. Pressure coil is highly inductive in nature. Whereas if you are observing wattmeter, pressure coil is highly non-inductive in nature. So energy meter pressure coil is highly inductive in nature. That is the most important point that you must observe. Because after reading wattmeter properties, you people are forget to observe this one. When you are observing the question in the examination, directly you are thinking that okay, in the wattmeter we saw pressure coil is non-inductive, energy meter also similar to that. You will be thinking like that. No, that is wrong. Pressure coil is highly inductive in nature when we are observing, when we are playing with the energy meter. So these things you must remember. This is very important. Okay. And the next thing, the deflection torque developed by the energy meter, that will be directly proportional to flux developed by the series coil and flux developed by the shunt coil. Flux developed by the series coil, flux developed by the shunt coil into the phase angle difference between them, sine of 90° minus the phase angle difference, phase angle afforded by these two fluxes. In terms of voltage parameter, we can define this deflection torque, that is directly proportional to load voltage into load current into cosine of phase angle cos pi, because we know sine of 90 minus pi. So this can be written as sine minus sine of pi minus 90. This can be written as minus sine pi minus 90. Sine of pi minus 90 will give you minus cos theta, minus into minus will become plus. So this will become, in terms of voltage, this can be written as VL IL into cos pi. So the deflection torque is directly proportional to the measurement of AC power. Correct, na sir? Deflection torque is directly proportional to the measurement of AC power. Next, here we will also remember some other torque, that is called braking torque. The next question is braking torque. What you have to remember is braking torque is directly proportional to the speed of the disc. Braking torque is directly proportional to speed of the disc. So as the speed is increases, braking torque also will increase. As the speed will decrease, braking torque also will decrease, since they all are always directly proportional to each other. The next thing is, you must know about some of the error that will be generated in the wattmeter. What type of error that will be generated in the wattmeter? The first error is pressure coil, that is creeping error. I will directly come to the name. So the first error name is, we are calling it as creeping error. You must know about the error generated by the energy meter, not wattmeter, that is energy meter. We are in energy meter. So what will happen, sir? As we are observing in the wattmeter, we are having two coils. One is moving coil and another one is pressure coil PC. When the moment, what we have to understand is the creeping current means moving coil is nothing but current coil. Pressure coil is nothing but voltage coil. We are observing in the current coil, there will be no current. In the current coil, there will be no current. But pressure coil has been energized. Pressure coil has been energized. I am repeating again. When we are discussing about creeping error, there will be no current in the current coil. Whereas the pressure coil has been energized. When the pressure coil is energized, what will happen is this will leads to let your disc to rotate slowly. Energy meter will rotate slowly. Energy meter will rotate slowly. This error is nothing but creeping error. As we are observing, the current coil is not carrying any current, whereas the pressure coil has been energized. During this condition, the energy meter starts rotating slowly. This error will be considered as, this is what we are calling, this effect is considered as creeping error. This is nothing but creeping error. One more question, most important. So what you have to remember is creeping means moving coil, current coil, there are two coils are there. Sorry, this is fixed coil, I'm sorry. Fixed coil is nothing but current coil, pressure coil is nothing but moving coil. Moving coil is nothing but pressure coil is nothing but voltage coil. When the voltage coil alone energized, fixed coil is not energized. Since fixed coil is carrying 0 ampere current, during this energy meter will be slowly rotating. That error is nothing but creeping error. That is one type of error that you must remember in your mind. So what is the reason for this? Is if you are considering the creeping error, it happened because the main reason is our static friction compensation. As we are observing, we have given one static friction compensation in the wattmeter also. So here the reason is, if you are having over voltages, static friction compensation Static friction compensation is one reason, and you can also consider over voltage is the another reason. The another reason is over voltages. And if the lubrications that you are giving now, if the lubrication is excessive, if you are giving excessive lubrication, that will also be a problem here. Excessive lubrication is another problem. Excessive lubrication. And if you are observing the stray magnetic field, that is another drawback. That is also one more reason for this stray magnetic field offered by the instruments. Sir, how to overcome this creeping error? The creeping error can be overcome by attaching a small iron piece on the edges of the disc. A small iron piece will be attached. We know the energy meter, it will be like this. So what will happen is a small iron piece will be attached at the edges of the disc like this. So by attaching the energy iron piece at the edges of the disc, we can avoid this creeping error. Okay, hope you understand what I am trying to say. So there will be one more problem in the wattmeter, that is called phantom loading. What is the another one? Not wattmeter, energy meter. I'm sorry. So regarding energy meter, you'll have to learn one more thing, that is called phantom loading. Phantom loading is also called fictitious loading. It is also called, we are also calling it as fictitious loading. We are also calling it as fictitious loading. So when we are observing, what will happen is phantom or fictitious loading. Actually, we are using this loading to reduce the energy losses due to the actual loading of the energy meter. So what we are doing is we are testing the energy meter with the help of the desired load current and nominal supply voltage with respect to power loss. That is nothing but phantom loading. So we are having, as we are having two coils, one is called current coil and another one is called pressure coil. Both coil has been energized. So with the help of, by energizing this, we are passing the rated current here separately, and by energizing this, we are passing the nominal voltage. And by keeping these two in mind, we will be measuring the power loss. So phantom loading is a type of loading which will be conducted directly in the laboratory. We are testing the energy meter with respect to the rated load. What will be the maximum power loss offered by the energy meter? So just to know the maximum power loss offered by the energy meter, this phantom or fictitious loading will be conducted in the laboratory. That is all about the measurement of voltage, current, power, energy. We have done all this. So all the active measurements are done. So the second part of this one is we are going to measure the value of resistance, inductance, capacitance, relative permeability, relative permittivity, measurements of permittivity and permeability. All these things is the next part. So these all things we will see in the next class. So this is all for this lecture. Further, if you have any doubts, you can always approach me. You can also drop your doubts in the comment section. You will be shortly answered. Thank you all.